Okay, so this is an interesting problem. Uh, Here we're just looking for the value of x, okay, but we are shown two triangles on a coordinate grid. You can see that these two triangles are kind of nestled into one another. There's one right here, and of course there's a bigger one as well. So two triangles. And we're looking for x, which is right here. X. Alright, so we are given, let me zoom in a little bit here. Alright, so all we are given is a couple of coordinate pairs. So how can we find the value of x with just the information given? Well, we're going to use what we know about similar figures, similar triangles, to get our answer. So the directions say to redraw the two triangles and label the sides correctly, and to use our ratios to find x. So let me redraw this little triangle here. I'll redraw it down here. Looks something like this. Alright, so let's find our sides. We can find our sides using our ordered pairs. Alright, so our sides, this side runs vertically, so we know that our vertical numbers are the y values. So what's the difference between our y values here? 3. We're looking at the distance between this point and this point. So 3 and 10. Well, the difference is 7. 10 minus 3 is 7. 3 plus 7 gets us to 10. So we know what that distance is. Now, can we find the distance between this point and this point to get our other side? Well, we know that if we're going, this side runs horizontally, and the numbers that run horizontally are our x values. Alright, so here we go from an x value of 0 for this point, and an x value of 14 for this point here. So the difference between those two numbers is just 14. 0 to 14. 14 units away. So now we've drawn our small triangle, and we have our two sides, our two legs, the dimensions that we need. So now let's look at our bigger triangle. So I will redraw it. And again, our little triangle is kind of nestled into our bigger one. So we have two triangles, but it looks kind of just like one. But now we're going to look at our big triangle, which is that overall triangle, and see what information we have. Alright, so let's look first at our vertical leg, since we started with that one on the other triangle. So we're looking now at the distance between this point and this point, this whole side here. Alright, and this leg runs vertically, so we know that our vertical values are our y values. Y runs up and down, so we're going to look at our y values. For this point, our y value is 3, and this point, our y value is 14. So the difference between those two is 11. 14 minus 3 is 11. 3 plus 11 is 14. Now, this is the side that we need to know more information about, because our horizontal leg, which runs from this point to this point, we're going to look at the x values for horizontal length. Our x value here is 0, but we are missing our x value here, which is what we're looking for. So we want to know what's this side length. So how do we find that information? Well, we use what we know about side-to-side ratios. These are similar figures, so we know three things about them. We know three things about similar figures. 1, same shape, which these are. 2, same angles, and 3, side-to-side ratios are equal. side-to-side ratios are equal. So what does that mean? What does that mean? Alright, so we're going to set up our ratios, and ratios that are equal, we know, are just proportions. We've already learned that. The proportions look like this. A proportion is a set of ratios that compares two things, two equal things. Alright, so here we have 7 and 14. That's our side-to-side ratio for our first shape. 7 for the vertical leg, 14 for the horizontal leg. 7 and 14 is our ratio. Now over here, our ratio, and again we want to keep it consistent since we have the smaller vertical leg on the top over here. We want to put that value on the top on this side as well. So we have 11 on top, and this is the side that we're missing. So we're going to label it as X. It's the unknown. So I'm going to use my calculator here. And remember, when we have a proportion problem, the way to solve it is to cross multiply first. Cross multiply and then divide by the leftovers. So first, let's cross multiply. So 14 times 11. 14 times 11 equals 154. 154 divided by the leftover number, which is 7, equals 22. So our missing value is 22. Which you can kind of see if you don't want to do all that cross multiplication and the division. If we set these ratios equal to one another as a proportion, we can just reduce down the fraction if we want. 7 over 14 reduces to 1/2. And if 11 is our top number over here, we know that our bottom number has to be 22 to equal 1/2. Alright, so our missing value is 22. Now let's look back up here at our ordered pair. So since this point is right on the y-axis, I'll close my calculator. Since this point is right on the y-axis, the x value is 0. So we know that this side length right here has to be 11 units long in this big triangle. This has to be 11. So the difference between 0 and what x value is 11? Well, it's 11. If we go from 0 and we need to count over 11 units, we wind up at 11, 14. So that's what the ordered pair is here, 11, 14. Now if this point was over 1, you know, if this whole shape was shifted over by 1 unit, you'd have to go over, you know, x would equal 12. But since it starts at the right on the y-axis, x is going to be the same as your side length. Okay, so hopefully that was helpful.